Hello everyone, this is the lecture for section 7.4, sum to product and product to sum formulas. So as I've explained in the previous sections for chapter 7, we are just learning more and more identities. These are sort of like standard identities that maybe in your travels, in your future studies, you might see. You might see them, you might not, but it's just good to know that they exist just in case, okay? The ones for this section, sum to product and product to sum. So grabbing some product of sines and cosines and then turning them into sums, or the other way around. If you got some, oh, I think I just said that one, right? If you have products of sines and cosines, turning them into sums, and if you have the sums of sines and cosines, turning them into products. These sometimes get used here and there. Whenever you need to do, grab a sum and turn it into a product, or the other way around, right? It's nice to know these, okay? But it's essentially the same as all the previous sections that we've been doing right now. I just give you these equations. I'm just more concerned with how you use them. The proofs for them, they are elegant, they are beautiful, but I am not concerned with it. If you really want to know, go into the chapter to look it up. Okay? All right. So for these, 1, 2, 3, and 4. So just how you can probably recognize, as we did in our previous sections, right? You just look at the one that you really need and then use that one. And that's it. Okay? So for example, this one, let me do this example, right? Cosine 3x times cosine 5x, and write it as a sum or a difference. Okay? Doesn't matter which one. It's a cosine times a sine. We need this one, so we need this other half. Okay? So then it'll go cosine of 3 theta, cosine of 5 theta. This is always good to do, right? You can make this alpha and this beta, call it whatever you need to, right? Just so that you can get the right order in the formula itself, right? And after that, we're off to the races. So hopefully you guys see that, right? 1/2 cosine. It's going to be alpha minus beta first, right? So it's going to be 3 theta minus 5 theta plus, and let me put big brackets right here, right? And there's going to be cosine of 3 theta plus 5 theta, and close brackets there. And this is going to be 1/2, so big brackets here, cosine 3 theta minus 5 theta is going to be minus 2 theta, okay? Plus cosine of 3 plus 5, that's 8 theta. We are done. Hopefully you guys see how simple that is. Okay? So then this right here, right? The cosine 3 theta, cosine 5 theta can be broken up into an addition as such. Done. We are donezos. Okay? Moving right along. It's quick checks. We'll do these in class. Okay? Next up, sums to products. Okay? So if you have the additions of a mixture of sines and cosines, and you need to collapse them into products, right? Then these are all the formulas, okay? Again, the proofs of these are very elegant. They're really, really pretty, at least for a mathematician like myself. But you really don't need to know the proof. If you really want to know, go in the book. I'm more concerned with how you use them, okay? So then, same thing as before, right? So I have a sine 4 theta, right, minus sine of 2 theta. Okay, it's always healthy to do it, alpha, beta, okay? And then you just choose the one that we really need. So this one is a sine minus a sine. Bam, we need this one. So we need this right-hand side to complete everything that we need, okay? 2, sine. And it's just healthy to write it out if you need to, right? 4 theta minus 2 theta over 2. Make sure I got the order right. Yep. Cosine. 4 theta plus 2. theta over 2. Okay, now we can simplify this out. 2 sine. 4 theta minus 2 theta, that's 2 theta over 2. I'm just doing the arithmetic here. 4 plus 2, that's 6 theta over 2. So this all reduces to 2 sine theta cosine 3 theta. And we are done. So what we did is we grabbed a difference, right? It was sine minus sine, and we turned it into a multiplication, okay? Not simple, okay? All right. Again, quick checks. Like I said, we'll do these in class, okay? Don't stress too much about how to do them right now, okay? Last thing I want to prove, right? We know how to sort of use these after the quick checks and after the examples. We know how to sort of grossly use them in angles, right? And you know, just at least to collapse or expand expressions, right? Sometimes you might need to use them to prove other identities, okay? And that's what we're going to do here, okay? It's exactly how you think it is. It is exactly how you think it is. So I want to prove that either the left-hand side, the name of the game is still the same. I'm going to either grab the left-hand side, turn it into the right, or grab the right, turn it into the left. Grab both ends, turning into something common, right? Or grab both ends and turn it into an already known trig identity, okay? Either one of the 4 game plans is still valid here, okay? For this case, I think I've mentioned multiple times before when we do proofs like these, right? You want to start with the messiest side. It looks like this is the messiest side. The left-hand side is the messiest side, right? So I'm going to grab the left-hand side, turn it into the right. Okay, so I'm going to write down some stuff before I get started. I'm going to write down the 2 identities from up above that I'm going to need, okay? And that is this one. So if I grab cosine of alpha, right, minus cosine of beta, right? If you look at your at your trig sheet, this is also there. It's probably in x's and y's though, but it's no different than the alpha and beta. It's going to be minus 2 sine alpha plus beta over 2 times sine of alpha minus beta over 2. Okay, that's the top one that we're going to need. And then the sine of alpha plus beta plus sine of beta. Okay, if you look again back at your sheet, right? 2 sine alpha plus beta over 2 cosine alpha minus beta over 2. Okay, so let me go ahead and start this out, right? So I'm going to start with this end, cosine of 4t minus cosine of 2t all over sine of 4t plus sine of 2t, okay? And we're basically going to hit it with the equation that we need from the ones that I just wrote down, all of these 2 right here. Okay, that's the reason why I wrote them down, okay? So the top needs our first one. The top one needs this one, okay? So then this is going to be cosine. Actually, let me go ahead and up. I didn't need the highlighter. I needed the dark pen. There we go. Minus 2 sine. That's going to be 4t plus 2t all over 2 sine 4t minus 2t all over 2 all divided by, right? Now we need the other one, the one that's below it, right? 2 sine 4t plus 2t all over 2 And then the other one is cosine 4t minus 2t all over 2. There you are. Okay, let's go ahead and do some of that arithmetic that's in between. So it's going to be a minus 2 sine 4 plus 2, that's 6, divided by 2, that's 3t. Sine 4 minus 2t, right? That's going to be 2t divided by 2, that's just t, divided by 2 sine 4 plus 2t, 4t plus 2t, divided by 2, that's going to be a 3t again. And then cosine 4t minus 2t, that's going to be positive 2t divided by 2, that's going to be t. Got it? Look, what happens, it's going to fall in our lap, essentially, right? So if you take a look, right, let me do the cancellations. There's a 2 on top, there's a 2 on the bottom, those go away. You have a sine 3t on top, you have a sine 3t on the bottom, those go away. So you get left with minus sine of t over cosine of t. And if you recall, that is just tangent of t, way back from chapter, whatever that was, chapter 5, I believe. So we got this all equal to negative tan t. Done. Okay. Again, we've got some quick checks here. We'll do these in class. Okay. And then lecture questions. Boom. This might be the shortest video ever. If you got any questions on the stuff that I just covered, ask me during our quick check time or come down to the tutoring center. I'll be able to help you out there. Okay. Besides that, happy studying.